Okay. All right. To solve the logarithmic equation, what have we done so far? What do we change it into? Exponential form. That's what goes in the blanks. Exponential form, and then you solve for it. That's exciting. All right, so this one's a little bit different. Take the second derivative, down in your head, spit nickels, it'll all work out. Okay, so it has an equal sign. You can put this into exponential form. So what's my base? X. What's my exponent? 1/6. And that's equal to √2. That should be easy to solve it. Yeah. Fair enough. So what do I want the exponent on the x to be? Right? Because if I have a x squared, I can square root it. If I have x cubed, I can cube root it. Really, I just want one x. So that means it has an exponent of 1. So what would I have to do to 1/6? What would I multiply 1/6 to get it to 6? So I'm going to take this and put it to the exponent of 6. But if I do it to this side, I have to also do it to this side. So this is going to be x. X equals 8. Oh, yes, that's the final answer. Sorry, So this is really hard to do because a 6 doesn't cancel that out. It's very confusing. So change the radical into a rational exponent. So x is going to be equal to 2 to the exponent 3. And x would be equal to 8. Easy peasy, right? So to eliminate fractions on that exponent, what am I going to multiply it by? The reciprocal. So if it's 2/3, I multiply it by 3/2. Makes sense. So you're going to multiply by the reciprocal. Because you always want that exponent of 1 when we're trying to solve for it. All right, so what am I going to do here? I'm going to do a log law, right? No one has any. This is from yesterday. This is a log law. They're added, so what am I doing to the arguments? Multiplying them. So I'm going to have a single log, so log base 2, and then have x times x plus 1 equals 1. I can't put, like, I have to do an exponential form here and an exponential form here, and it would just get very confusing. So apply your log law first. You're dealing with a single log. You don't want to change it into exponential form unless you're dealing with a single log. So what's the magic that's going to happen here? What's the base? What's the exponent? 1. What's the argument? X times x plus 1. That's supposed to be a nice bracket. 1. So now to solve this, it's just basic algebra. So 2 equals x squared plus x. I have an x squared, so what am I going to do? 2 to the other side. So 0 equals x squared plus x minus 2. Suggestions? Okay. All right, that just took me a little bit longer than I should have. Now we are going to talk about a rejection. I'm going to reject an answer. Just pick one, just randomly. Okay. You can't take a logarithm of a negative number. voting you off the other. I'm voting you off the other. Okay, so where would this go? So if we put -2 in here, let's do the math. So if we substitute -2 in here, we have log base 2, -2 times -2 plus 1. Probably isn't a great example. So this would be +2. This one isn't a great example. It does work. This one actually works, but it doesn't always work when it's negative. So when we put a negative in here, if this were a negative answer, let's say this was +3, let's just say this was +3 for now, my answer would be -2 here. And there's no exponent that you will put on the base to change it from a positive number to a negative number. Does that make sense to everybody? Like if I have 2 exponent -400, is that going to change if we evaluate that? Is that going to be a negative number? No. And we're only dealing with logarithms with positive bases. We said that at the beginning. So there's no exponent that will change the argument to negative. Make sense? So this gets rejected. And also my little blurb on the side. So arguments can never be a negative number. And okay, so to back it up even further, this makes sense. Let's just look at the original piece here. Kevin, this is for you. If we put it in this original piece here, log base 2, x was -2. What exponent would we put on the base of 2 that would give me a -2? There's nothing. 2 to the exponent k equals -2. That's never going to happen. Because if I have a negative exponent, that just means I'm getting a really small fraction. There's nothing that will turn a positive base into a negative base. Doesn't matter. Sure. So if you go back to here, this is what negates it. It's kind of like when we do those area questions and you have to solve for x. And you've got like a box, let's say that is x here, this is 2x plus 1, let's say 5, that'll work. And this is 3x plus 3 here, and we get a -1 for x. Well, if I put -1 in here, it will work. If I put -1 in here, will it work? It's 0. Probably won't be great. And in this dimension, it will be negative. So just because it works in one place, it has to work in all of them in order to be a valid answer. Yeah. Here's the thing. And you can't have a negative argument. So you should be checking in the original. If it was this one and there was a -2 in it, would it work? No. So it doesn't work in either place. It does work when they're multiplied together because negative times by negative gives me a positive, hence over wherever I put that. But it doesn't work in the expanded group. So it has to work everywhere. No, it's rejected. It's kind of a known truth. It is not kind of, it is a known truth. So you just reject it. It's kind of like your non-permissible values. If you stated your non-permissible values, you don't have to prove why you're rejecting it. All right. We've done this before. We kind of talked about it before. Remember when we did exponents, like if this is 2 to the exponent 3 and this is 2 to the exponent 2x. What happens to those bases? What do we do with those bases? We drop them. We don't cancel them out. We don't divide them out. We just drop them. And we just simply bring down the 3 equals 2x. So if we can do it for exponents, we can do it for logs. Math doesn't really change much. But here's the deal. They have to be the same base. And if you actually cross it out or divide out the log, you're going to get a full mark reduction for a concept error. You can't do that because you need to take a log of an argument. You can't just divide up the log part of it without the argument. Okay, so looking at this, what's the first thing I'm going to do? Now notice there's a single log and a single log. So what am I going to do? What am I going to do? This is yesterday's lesson. I need to make this side a single log. That's step one, make it a single log. So this is going to be log base 2, x times x minus 2 equals log base 2, 3. So I have a single log and single log. They have to be the same basis. Are they the same basis? Yeah. So what can I do with them? Drop them. So my next line should be x times x minus 2 equals 3, x squared minus 2x minus 3 equals 0. So I'm going to have x equals a positive 3 and a negative 1. What am I going to do? I have to reject the negative 1 because if I go back up here and put negative 1 in there, it doesn't work. If I put negative 1 in here, it doesn't work. So this gets rejected. Right, but it's only worked out in the single log version. If you go back up to this one, it doesn't work in the expanded version. Because it's a negative times a negative, so it's going to work in three logs. Okay. This is the stuff you needed to know here. Who are you texting? Who's more important than us? You really are going to get any credit. Even though I have the power just to like start deleting things from your transcript. Yeah, that English, just gone though. You can't graduate with other though. People talk to you that. Yeah. Not after comments like that. Yeah. Yeah. We are friends off. Yeah, that hurts. When you say everybody is more important than us, ouch. But Kevin did. I didn't think I would hear it. Ouch. Still cuts me deep. Still cuts me deep. Okay, can I do anything with this? Am I dropping logs? You have to do the stuff first. So this side is multiply. This side is going to be divide. So I'm going to have log base 5 2t times t minus 4 equals log base 5 48 divided by 2. The argument is divided by 2, not the whole logarithm. So you need to be specific because I'm going to start deducting marks. If you put this whole thing over 2, I'm going to be upset. That's a concept error. I think it would be a transfer. No, but just make sure that line is under 48. Don't you dare put the line under the whole log, or else seems reasonable. Seems like a reasonable threat. 38 divided by 2 is a whopping 24. Single logs on both sides. Single logs on both sides. So I'm just going to eliminate them. And I've got 2t squared minus 8t minus 24 equals 0. I think I should factor that 2, make my life a lot simpler. Would you guys have used the quadratic formula on this one? Would you have seen that though? I know Rita wasn't struggle with it. Yeah, because it does save you a lot of time. So what are we going to use for my factors?
that two just get disappeared?
Why not? What's the?
One we had to-
This one, it doesn't disappear, but we're not gonna set, we can set 2 equal to 0. There's no variable to solve there.
Yeah.
So I'm only concerned about what the values of t are. What am I gonna do here? I'm gonna reject the 2. All right, so this one, last one, throwing a curveball at you. How is it different? Right away looking at it, how is it different than the other ones? There's no log on that right-hand side. Okay, you can only drop logs when there's a single log on the left-hand side and a single log on the right-hand side. Okay, if there's not, then you need to put it in exponential form. So this is going to be log base 5. And I'm going to have 3x, we're going to do this all in my head, minus 9x plus 1, so minus 8x minus 3 equals 3. All I did was multiply these two arguments together. I'm fine if you skip steps and go right to that. I'm also fine if you show the 2 factors and then do the multiplying. Can't, I've already got a log here, but can't log both sides. Can't log just one side or anything. So if you have a log on one side and a number on the other, guess what you're going to do? Put it in exponential form. So this is going to be 5. The exponent 3 equals 3x squared minus 8x minus 3. Yes, Canal. 3x times negative 3 is negative 9, plus the 1x gives me the negative 8. What's 5 to the exponent 3? 1, 2, 5. Yeah, you're with us? Thank you for joining the land of the living. So, can I call it factor, you think? So, we can do that. Or, in this case, where are we going to go? Quadratic formula. Like, I think that in a case like this, 3 times 1 to the 8, we're getting into a lot of big factors. I'd probably use the quadratic formula. It actually isn't terrible, the quadratic formula for this one. Your answers are 8 and negative 16 over 3. So what am I going to do? Reject the negative. Okay, so what do you do if you have a single log on either side of the equation? Drop the log. If you have a log on one side of the equation, use exponential form. Okay. Who's doing chapter 8? Matthew? Matthew. Because I think I would have added that to like my cheat sheet notes.
I just said that you guys.
Also, we can all get lunch.
That was.
Was that wrong?
I said no state.
Okay. All right. Okay. Ready?
Yeah.
Okay. There's no logs here. There's no logs. So that's nice. So here, like in chapter 7, the only skill we had was get them to both the same base 3 number, right? And then once there's the base 3 numbers, then we can drop them so they're equal, and then we can solve them. Well, that doesn't work when they're not nice. It's not 3 and 27. Jerome, do you think you can wake up? So between Canal back there, Carson on his phone, you nap in front row.
I don't know my phone system.
I appreciate that. You're not even here. I quit. Okay, for the rest of us, so this isn't gonna work getting them to same basis. It's just not, our chapter 7 stuff has let us down. So now what we're gonna do is we're going to log both sides. All I want you to do is write the word log in front of the 3 to the exponent x and write a log in front of the 4. When I say log both sides, that's all I want you to do. What kind of logs did I add there? I added base 10 logs. There's something else I need to do. Got to move the x in front. So now that they're all on the same level, I can start doing stuff. What's the operation between the x and the log 3? Multiply. So what's the opposite to multiply? Divide. Do you guys just heard me say you can't divide a log out? Remember I said that on the other page? No, I didn't lie. What I said was you can't just divide the log without the argument. Do you know what I'm saying? Does that make sense? You can't leave the argument behind and just take the log in the base. You have to take it as like a whole thing. So when we did this one, I take the log, I took the base of 10, and I'm taking the argument of 3. So I'm taking the whole thing as a package. You cannot separate it. Okay? So I'm able to do that. So when you're handy dandy calculator, what do you deal with? What does your calculator deal with? Base 10 logs. So you could do this in your calculator. Can I do that? Here's a question.
It's the same, it's just a lot of work.
Is that the same? It is not the same. So if you put this in your calculator, where'd my calculator go? I really should have a calculator for me. We can, we really can. So we did log 4, close my brackets, divide by log 3, close my brackets, and I get 1.26. If I were to do just the arguments divided, log 4 divided by 3, close my brackets, it's a completely different answer. Because if you put this in expanded form, what does that mean? Log 4 subtract log 3. That's not the same thing as division. This is not equivalent. I don't like showing you the wrong way of doing it, but just a lot of students make mistakes that they think that they can just put this in their calculator, like those logs cancel each other out. Why does the word log not cancel each other out? You can't divide just the log, it's going to be the log base and argument. What did you say? 1.26?
Yeah.
Sure. All right, so for this one, I'm going to hit pause. You guys are going to log both sides and just simplify it. Just try that for a moment. Okay, so I've got log. We'll just do this because you guys are the smart kids. Did you put your x plus 4 in brackets? They need to be. Good smart kids. How come they need to be in brackets? Because it's one exponent. That whole thing is multiplied by log 7. What's the base on the logs? I'm just gonna beat you up about that for a little while longer. So what you're gonna do, are you guys ready? You're gonna do some distribution. So you're gonna take your log 7, multiply it by x, and you're gonna take your log 7 and multiply it by 4. So I have 3x log base 2 equals x log 7 plus 4 log 7. That's exciting. Something like this will be on your provincial exam, guaranteed. There will be, like if you go through, there's a lot of chapter 8 content. On what? I don't know. Well, they're just, well, chapter 8, chapter 4, 5. Okay. So I'm going to bring all the x's to the left-hand side. So I got 3x log 2 minus x log 7 equals 4 log 7. Can I subtract these and get 2x? The arguments are different, so I can't subtract them. They're totally different things. What I can do, though, is I can common factor out the letter x. Okay, this, like I said, this is one that will be, this type will be on exams and definitely will be on your test. Okay, I want to get x by itself. What operation is between x and that bracket? So that means we're going to divide by everything in that bracket. And if I do it to one side, I have to do it to the other. So I have 3 log 2 minus. You cannot cancel out this and this. Please don't do that. It will die somewhere. Don't be responsible yet. Since you guys don't think I'm important, I'm going to first solve helpless animals under the box. So how would we do this in our calculator? Use brackets. I like it. Use a lot of brackets. Okay, so my top was 4 log 7. You got to close that bracket. Divide by bracket. 3 log 2. Close that bracket. Minus log 7. Close that bracket. Close the big bracket. Woo, lots of bracket use there. And that is the correct answer. So x is equal to 58.29. 29 or 2.8?
No, actually, my answer.
You're wrong. Sorry, that was, came up very formal. You are wrong. No, that wasn't right. How did you do that? Did you skip a bracket?
4 log 7.
Mm-hmm.
7 divided by.
Close your log 7 bracket?
Yes.
Okay.
Divided by.
Yep. Mm-hmm. Close the bracket. Uh-huh. Can you
Oh, wait.
wait? Hold on. Okay. Okay. This is exciting. More stuff. You don't like stuff. Step 1, what are we doing? Logging. A whole new career for us. Brackets are gonna be your friends a lot in the logarithm. Okay, so arguments are multiplied. I need to now expand them. Because that x isn't applied to the 2, so I need to get them separated. Because I can't move that x out to the front, because that would mean that the x is applied to the 2 and the 3, which it isn't showing me in the question that it isn't. So I need to expand using logarithm laws. So this would be log 2 plus x log 3. Are you guys comfortable that I skipped a step there? No? Do you want me to go back up? Well, I don't want to screw up your notes. You're good? And that x plus 1 needs to go in brackets. And then we got log 5. What's the base on these logs? 10. Okay, what do? We do what? You just do it. Okay, I'll just do it. Gonna do the thing. Distribute. So I've got x times log 5 plus log 5. Do I need to put the 1 in front? We're all okay with that? Okay, what do we do now? What everything? No, anything with an x comes to the left. Anything that doesn't have an x in it goes to the right. So I'm going to have x log 3 minus x log 5 equals log 5 minus log 2. I mean, we could have done it in many steps, but I think we're advanced in our algebra that we can just do that. Can I subtract an x log 3 from an x log 5 and get 0? No, because they have different arguments. So I get a common factor that x out. Now what? Divide by what's in the brackets, and I have to do that to both sides. Pardon? Okay, I'll just say the answer.
I don't think it's 1.79. Everybody knows.
Maybe 1.79. Okay, why can this x be negative? Go back to the original. Where does the x live? Can exponents be negative? Right. That makes sense to everybody? So don't reject it. Make sure you know what it is before you reject it. So we can have negative exponents. That's not an issue. We know how to deal with those. I told you guys that on the provincial exam, I think there was a logarithm question, your calculator one, I think it's question 2 in your exam review. It's not a formula that you saw or whatever year we did, I think in 2017 January. It wasn't an equation that was used in what we taught, but the idea is I can give you any equation with an unknown exponent, and you can use your knowledge of logs to solve it. So these were warned that you may get an example on an exam or a test of a formula that you're not comfortable with. And I'm sorry, but it's impossible for me to show you all the possible options. You do need to remember that aspect from you. That might be a good to remember. But go back to 2. The half-life would be A equals A initial times 1/2 to the exponent t, or to the exponent x. There was a list, like right up in the top, 8.2, I think, and it said this is how, oh, maybe it was in chapter 7. It was in chapter 7, sorry, 7.3. Okay, I digress. So I need you to be emotionally prepared to see stuff you've never seen before. It is. But you got the skills. Okay, paleontologists can estimate the size of a dinosaur from an incomplete skeletal remains. Has anybody seen dinosaur bones in the museum? Like, yeah, of course you have. Okay, I hadn't until like I was 24. So this was a whole new thing to me. But when you go into a museum, it shows you, like when I was in the Royal Ontario Museum this year, it shows you what bones are like real fossils, and then all these ones are like synthetic ones that they made to make a whole replica, right? So this stuff would be used to figure out how long that bone is if you had no other parts that would work with it. They use it all the time, like I said, Royal Ontario Museum, I was there this summer, checking out, dinosaurs, as everybody does on the summer vacation. So the relationship between the length as in meters of the skull and the body mass in kilograms can be expressed using the logarithmic equation of that. Determine the body mass to the nearest kilogram of an Albertosaurus with a skull length of 0.78 meters. Okay, so where does this go? What is that? Is that M or is it S? S. It's a skull length. So we're going to have 3.6022 logs. What's the base on these logs? 10, 20. We're up to 30 now. All right. Okay. So what are we going to do? What are we going to do? We're gonna do some math. You have all the information to evaluate this log. You can do that in your calculator because it's a base 10, right? So you can do that in your calculator. So all you need to do is take 3.6022 and we're going to multiply that by log 0.78. I need to close brackets on that thing. And we get that number. Gross. Let's use 4 decimal places. I'm only committing to 4. So this is negative 0.3887. Equals log m minus 3.4444. I don't want to jinx it, but my things are working pretty well today. Okay. What do I do? What am I bringing to the other side? I'm bringing that constant over to the other side. No. So what am I going to get? So I'll go back to my calculator. So I'm going to be adding 3.1. So let's use 4 decimal places again. Hey, should I be using all the decimal places or should I be rounding? I shouldn't be rounding. I have to use them all. Right? Luckily I went back and used the answer from the line above. So even though I'm only writing 4 down, you need to make sure you're using all the decimal places. The only time you actually round is in the answer. If you round too soon, we call it a round error, and you get a half mark deduction, which is E6, rounding too early. This is all chemistry. Okay, I have a single log. How do I do it? Exponential form. When you have a single log, you can't log a log. So you've already got logs, so if you don't have a log on the side, you know that you're gonna go to exponential form. What's my base? And what's my exponent? 3.0557 equals the argument of m. So I'm gonna go back to my handy dandy calculator. I'm gonna put 10 to the exponent, second function, negative sign, and it will pull the answer from the prior line. Really? Right, it's a little bit older model, but that's how you do it. You do second function and the negative sign. You would have had to rewrite that whole thing. Sorry, I have to tell me to give you that little nugget of information. What am I supposed to be rounding to? The nearest kilogram. So what am I rounding to? 1,137 kilograms. So let's say that was a 2-mark question on a provincial exam. If you rounded too early, you would have lost a half mark. If you forgot your units of measure, you would have lost a half mark. So all of a sudden, you're down to 1 out of 2 for simple things that have nothing to do with your knowledge of law. A lot of words. Okay. The rate at which an organism duplicates is called the doubling period. So this is opposite to our half-life, the doubling. Original number is doubled over the period E. E. coli is a rod-shaped bacterium commonly found in the intestinal tract of warm-blooded animals. That's us. Some strains of E. coli can cause serious food poisoning in humans. Suppose a biologist originally estimates the number of E. coli bacteria in his culture to be 1,000. After 90 minutes, the estimated count is 19,500. What is the doubling period of E. coli to the nearest minute? 3? Okay, 3 minutes. 3 minutes, that's your guesstimate? All right. So I guess what the question is what are we solving for? So what's time? Or what's T? I'm not going to run that one. D is, what is the actual doubling period? Okay, so we get these questions all the time relating to investments and how an investment doubles. So FYI, that's always a fun one to pop up there. So NT, what is NT? The 19,000, that's my finish, right? So that's 19,500 equals an initial. So that's my initial amount, which is 1,000. My 2 is my base, which is constant. And I have the time. How much time has passed? 90 minutes. Over D, which I'm trying to find. Is there any logs anywhere in here? No. And I'm trying to solve for D. So you can anticipate this is one where you're going to log both sides. Okay? Not yet. What am I going to do? I need to get the base and the exponent by themselves. I need to isolate the power. Divided by who? What? I want to isolate this. So what am I dividing it? No, I'm dividing it with 1,000. Okay? So I'm going to have 19.5 on this side equals 2 to the exponent 90 over D. Now I want to solve for the exponent. I have no logs, so anticipate that you're going to log both sides. So log of 19.5 equals 90 over D log 2. All right, what are we gonna do? Right, who, what? You can multiply both sides. Because it's like a coefficient. This is like a coefficient now, it's not like an exponent. So getting rid of the denominator, so we're gonna multiply both sides by d. So I've got d log 19.5 equals 90 log 2. Yep. Okay, I'm not telling you the answer.
Start with the number if you want to do. Is it 30?
I'd actually like you guys to try this on your calculator, just to make sure that you understand how to put these logs in. Okay, so we're supposed to round to the nearest minute. Seven times. Almost. So if you put in your calculator right, you should get 21 minutes. Okay?